Hello everyone. This is this video is all about async web API methods. So I believe that once once in your career, once in your development career, you must have heard about async web API methods. So maybe your senior or maybe your architect may speak like make your methods async so they can handle more requests. So and you wonder like why this simple keyword async can can handle the can handle more requests. If I remove the async, it handle less number of requests, and when I add this it handles more number of requests. How is it possible? So let me tell you what happens is, okay, so what happens is you mm, in our system, in our application, we have something called as thread pool. Okay, so this is thread pool. Okay, so I'm sorry about the writing, but that's not our concern right now. Okay, so this is our thread pool. So we have, suppose, one, two, three, four threads available in the thread pool. Now we have a web method. Suppose this is a get method. Okay, so this is the controller get method. Now what will happen is uh, whenever you whenever a request will come to this get method, so this method to get processed need one thread. So this thread will be assigned to this method. Now the second request will come. To serve the second request, the another available thread will be assigned to this request. But there is one condition, like suppose this get method is returning the response within very few milliseconds. So what will happen, the first one will be assigned to this process, and it after getting the execution of get method, when the client will receive the response, this thread will again go to the thread pool and it will again become available to be assigned to some other process, to some other request, right? Now suppose I'm taking the example of something like, suppose this get method is a long running process. It takes around 2 minutes. Okay, it takes around 2 minutes. Now there are four threads available in the beginning. This first thread got assigned to first request. Okay, now the second thread, now this thread was running, this thread was still in process, so it was not released from the first request because the first request was still will still take 2 minutes to get completed. So the second request will come. Now will the second thread will be assigned to the second request. Okay, now this request will also take another 2 minutes to get executed, and once that is completed, the second thread will go to this one, to the this thread pool to get available. Now suppose this 2 minutes get method got five requests at the same time. So what will happen? Four threads, first, second, third, and fourth. Okay, so these four threads were assigned to four requests. Now they all are in process. Now the fifth request will come. But in thread pool, we do not have any fifth thread to get assigned to the fifth request. So in that case, the fifth request will be blocked until any four of these complete their work and again they go to thread pool. So the first one which will come back, probably that will be the first one. The first one will complete its work, then second, third and fourth. That first one will go to the thread pool, and then the fifth request will be handled by the first thread only, right? Because that is the only one available. Rest of the three, second, third and fourth, was still used for the second, third and fourth request. So in this case, what happened, that means if we have suppose 1000 requests in our project, okay, so only 1000 threads should be there, right? That makes sense. Yes, if we have 2000 requests in our project, no matter which method it is getting called, it may call get clients, it may call get employees, like that. Okay, so so what will happen, uh, in case our project is getting 2000 requests simultaneously at the same time, okay, so 2000 threads will be required. Okay, so this is the normal scenario. This is the scenario which we create when we create web API methods in a simplest way without async. So this is the normal scenario. But what happens in case when we use async keyword, when we use async programming, when we do async programming, what happens is, suppose this was your get method, right, which was taking 2 minutes. This was your get method which was taking 2 minutes. Okay, okay, now the first request came. Okay, and and this was your pool where one, two, three, four threads were there. Now you are using async keyword, please keep in mind. Now you are doing async programming. Okay, what will happen when the first request will come? First request will go to, will get, the first thread will assign to the first request, here mapped with the first request. Now they will see, the program will see that it is going to take 2 minutes. Okay, it is still running. Now it is still running, it will take some time because we will mark it to wait somewhere. Okay, so we will say that okay, the first thread is running, but uh, wait here for some time until this gets completed. So in that case, the first thread will not wait here. The first thread will again go to the thread pool, it will go to the pavilion again. Okay, now the second request will come. The second request, the first thread which is again available, then go for the second request also, and the second request also says that okay, wait for 2 minutes. So it will not wait here, it will again go to the thread pool, and once the first request 2 minutes will be completed, any available threads will go to serve it, will go to serve and continue the process. So that is the case. In this case, you can take an example of a restaurant. When you go to a restaurant, there are suppose one, two, three customers, right? This is C1, this is C2, and this is C3. Now this is the kitchen. This is the kitchen. Okay, let me tell you with new thing here. Okay, new page here. So this is customer 1. Okay, this is customer 2, and this is customer 3. And in the thread pool here, you can say we have waiter 1, waiter 2, okay, and waiter 3. Three waiters are there. And this is your kitchen where the food is getting prepared. Now what happens, take these customers as requests, take these waiters as the threads, and take this kitchen as some other process that that is also involved. Now when the first customer came, from this basket, first waiter gets assigned to it. Okay, now what will happen, that if this customer says I need these things, these four things, so that waiter will go to the kitchen, and the kitchen man will say, the chef will say that it will take 30 minutes. Okay, so it will go to customer and it will say that wait for 30 minutes, and again that waiter will go to the queue. Again that waiter will go in the available position. Now the second customer will come. Now the second customer will say, okay, I need, where is the waiter? So this first waiter is again available. This first waiter will go to the customer 2 also. Okay, and customer 2 will say again the same thing, I need these four things. The waiter will go to the kitchen. It will say, okay, wait for 40 minutes. I need to prepare something else also. Okay, for the customer 1. So the waiter will go to customer 2 and wait for 30 minutes, and again it will go in the available position. So whenever the process is taking place, and the waiter should not wait here. So what happens when we do not use async keywords? So first waiter gets assigned to this, second waiter gets assigned to this customer, and the third waiter gets assigned to customer 3. Now they all together come here, okay, to say that, okay, prepare all the respective food, and the kitchen man says, okay, wait for 30 minutes, all of you. So they stays here. Okay, they stays here like fools. Okay, they do not, I'm not giving the word fool to waiters, but I'm giving the word fool to the process which we use technically in the web API methods. So the thread waits here. Okay, if the thread knows that I will have no work until 30 minutes, then they should be in available position, right? So in this case when you use a sync keyword, you make all your methods from your business logic to data layer to your first layer. If you make all the methods async, then you will see there will be a drastic performance improvement there. Okay, uh, but as I said you, if three customer, three waiters, now in the normal, in the traditional thing, what will the we do not have waiter 4, right? And the customer 4 will wait because all three waiters are standing here, right? So it will, this customer will wait. So either restaurant will have to hire someone, but hiring a someone means creating a thread. So both are lengthy process. They should not be there until it is needed, because we have the options to utilize the resources. Okay, so that's the concept. Now can we see this practically? Absolutely yes, we can see this practically, whether it will improve the performance or decrease the performance. How? This is all not theoretical. Everything which is theoretical, it can be visible. Okay, so that's the that's our agenda. We have to see this thing practically. So this is the concept. Okay, but we will do our practical in the next video. Thank you for watching this. Bye bye, have a nice day.